Students, in this video we are going to learn about types of relations. So first we will see what is empty relation or void relation. You already know that relation is the subset of Cartesian product of A cross B. So with that mind we can go ahead with empty relation. A relation R on set A, that is set A means here first set as well as second set is a set. So empty relation on a relation R on a set A is called empty or void relation if no element of A is related to any element of A, that is relation set is equal to pi set. Now with an example you can have a clear idea about it. Let A is a set which contains the elements 1, 2, 3 and a relation R is defined as a set R is defined as it contains the elements set of ordered pairs A, B such that A minus B is 12. Show that R is an empty relation on set A. Now we need first element. So if you look at this, now we need to write A cross A because our relation R is a subset of A cross A. So it is compared with first element of A is connected with each and every element of set A. So 1, 1, 1, 2, 1, 3 and then 2, 1, 2, 2, 2, 3 and then 3, 1 and then 3, 2, 3, 3 are the elements of the set A cross A, and R is a set which contains this a set of ordered pairs A, B such that A minus B should be equal to 12. If you take any of these values and if you subtract it, the result should be 12. If you subtract 3 minus the answer is 12. It does not come here. 3 minus 2 means 1. Again this relation should be defined based on A minus B is equal to 12. None of these elements will produce this result. Hence this set R is an empty set. Hence you know that A cross A is a Cartesian product. Relation means the subset of A cross A. All the sets contain null set as its subset. Hence this relation R can be called as an empty relation on set A. I hope you understand this. Now we move on to next question. Let A be the set of all students of a boys school. You just make a note of it. Set of all students of a boys school. Show that the relation R in A given by R is a set which contains the elements set of ordered pairs in which A, B are the elements, and such that A is a sister of B. A is a sister means A must be a girl, but here we are talking about boys school. Hence because set A contains all students of a boys school, hence set A must contain only boys. But here the first element belongs to first set, right? So this A is a sister. It means that A is a girl, but it is not. But the girls is not available in set A. Hence it is the empty relation. Hence R is a empty relation, and you know that A cross A will have subset as empty set because we know that empty set is a subset of all the set. Hence it is the empty relation. I hope you understand this empty relation. Now we move on to next concept, that is universal relation. Universal relation, it is a relation. You know that it is the subset of Cartesian product of A cross B. Otherwise we have two elements, Cartesian product of two sets. A relation R on set A. On set A means A cross A. So a relation R on a set A is called universal relation if each element of A is related to every element of A. You make a note of this word universal. So that is R is equal to A cross A. Now with an example you can have clear idea about universal relation. Let set A contains the elements 1, 2 and set R is defined as it contains the elements, that is set of ordered pairs as A, B. A plus B should be greater than 0. Here if you take this if you write A cross A, it will be equal to 1 comma 1, 1 comma 2, and then 2 comma 1, 2 comma 2. If you take the first element is A, second element is A. If you add these two, answer is 2, it should be greater than 2. Hence this element can be a part of this set R. And then 1 comma 2, if you add these two, answer is 3. A plus B is greater than 0. Hence this 1 comma 2 can be a part of this set R. And then if you take 2 comma 1, A is 2, B is 1. If you add it, you are getting the answer 3, which is greater than 0. Hence this ordered pair can be present in the relation set R. And then 2 comma 2, if you give A as 2, B is 2, and the answer is 4, which is greater than 0. Hence this ordered pair can be present in this set. If you observe this set R is equal to A cross A, that is Cartesian product of on set A. Hence R is a universal relation on set A. With this example, you can understand very clearly what they mean by universal relation. Now we move on to next question. Let A be the set of all students of a boys school. Show that relation R in set A given by the set R which contains the elements ordered pair A comma B such that the difference between the heights of A and B is less than 3 meter. So definitely the distance between the heights of A and B is less than 3 means all the students will be the part of it. Hence here this R, the set R contains all the elements in A cross A. Hence R is a universal relation on set A. Now we must remember this remark. These are important points. Void and universal relations are called trivial relations. Please make a note of it. Void relation and universal relations are together called as trivial relations. Void relation is the smallest relation because it does not have any element, whereas universal relation is the largest relation on any set because it contains all the elements in Cartesian product of two elements. I hope you understand this concept very clearly. Now we move on to next important one, that is identity relation. Identity relation means, please be very careful about it. In future you will see about reflexive relation. Both of them will confuse you, so you must be very clear with identity relation. Identity relation means it is a relation R on a set A is called identity relation if every element of A is related to itself only. Please make a note of this word every 1 minute, students. Students, this word is very important. I repeat it once again. A relation R on a set A is called identity relation if every element of A, it means each and every element in set A should be related to itself only. That is, set R contains the set of ordered pairs A comma A such that A belongs to A. We denote identity relation on set A by IA. So with an example you can understand this concept very clearly. Now we take a set which contains the elements 1, 2, 3 and we define R as, because R identity relation means R contains set of all elements A comma B, A minus B equal to 0. Show that R is an identity relation on set A. Here we have a set which contains A 1, 2, 3. So if we write A cross A, we are getting all these expressions. We need to consider the set R contains elements. If we take the set of ordered pair, difference will be 0 between them. If you consider this 1 comma 1, 1 minus 1 will give us 0. Hence 1 comma 1 will be a part of this set R. And then 1 comma 2, A value is equal to 1, B value is equal to 2. If you use 1 minus 2 means answer is minus 1. Hence this element set of ordered pair cannot be the part of relation R. Similarly 1 comma 3, 2 comma 1. Now consider this 2 comma 2. A value is equal to 2, B value is equal to 2. When you find out the difference, the answer is 0. Hence this set or 2 comma 2 can be a part of this relation, and then 2 comma 3 cannot be present, 3 comma 1, 3 comma 2. Now we can consider this 3 comma 3. 3 minus 3 gives us 0, hence 3 comma 3 can be the part of it. Now if you observe this, every element of set A, that is 1, 2, 3 is related to itself, because if you observe the first element 1 is there, second element 2 is there, third element 3 is there. They are all